what we're doing in section 4-5, guys, is we're going to do a lot of what they call indirect measurement. This is actually a real-life application of where similar figures come in. Tighten, Chromebook should be closed. Come on, Chromebook should be closed. This is the third time I've said that. Now, indirect measurement has to deal with if there's something that it is not convenient for us to measure directly, as in, if there's something that, is too far away or it's too tall and so it's very difficult to measure, then we can use indirect measurement. Common example of indirect measurement is if you had, say, a flagpole, and let's say I told you guys that I wanted you to find out how tall our flagpole is out in front of the school. Now, pretty big is not a measurement. Now, what's going to be the problem with measuring it with a tape measure?
It's too short. It's far away.
First of all, your tape measure is probably one single tape measure is going to be too short to measure. Okay, Allie, that's homework. It needs to be done at home. You need to be paying attention to this right now. Now, all right. So for indirect measurement, we are going to be measuring something that is not necessarily convenient to measure. Sam, just sit up, please. Now, a tape measure would be short. Plus, even if you had a tape measure that would be long enough, what would be the next issue with measuring this?
How are you going to get up there?
Right. You're going to have to somehow be able to get to the top of this to figure out how far it is from the top to the bottom, right? Now, guys, okay, if I gave you guys this assignment, though, do you have access to a fire truck? No. Okay, guys, enough. Now, indirect measurement is going to use the concept of similar figures. Now, what we do with indirect measurement is you can't measure the flagpole, given that you're students and you don't have access to really tall ladders or anything. But what you could measure is the length of the shadow that the flagpole casts on the ground.
Is this science? Don't you have to do this? Where's the science?
No, you have to do it in 7th grade. We're about to have to do it.
I know how to do it.
Now, okay, because direct measurement is a scientific concept too. Math and science are very tied together. Guys, y'all are seriously starting to annoy me with the constant interruptions. Wait on questions until the end. Wait on comments till the end. I'm going to explain to you how to do this. Now, you can't measure the flagpole itself, but you can measure the shadow. And why that's helpful is because the shadow is formed by the sun, and the sun is going to be hitting the flagpole at a specific angle, depending on the time of day, right? You have longer shadows if it's later in the day, shorter shadows if it's, if the sun's more directly overhead. So the angle of the sun is what determines how long that shadow is, right? Now, here's the thing. Other things that are out at the same time of day will have the same angle as far as how the sun hits them, correct? So if you're outside standing next to the flagpole, you can also measure the shadow that you make. And now here's the reason why this is helpful, is because I don't know how tall this flagpole is. But I can figure out this measurement here, right, of the shadow. I can figure out this shadow here, but I also can figure out the height of the person standing next to it, right? These are similar figures. Because the sun is hitting at the same angle,
I'm checking that.
Not every question is going to be an indirect measurement question like this. Other examples, if you think the very first example I gave you guys when we did a similar figures, we talked about a flag and we talked about how a flag has to be similar, no matter what. If you looked at official flags, they're always rectangular. They're always a little bit longer than they are wide, but I mean, it's very specific. You're never going to find an American flag that's, really long and narrow, because that wouldn't be official. To be an official American flag, it has to be not square, rectangular, but a lot closer to square. I mean, look at our flag. I mean, it's a rectangle, but
It's a square.
it's close to being a square. It's not a whole lot longer than it is wide, right? So when you're looking at it, though, the thing is they're going to be proportional. We also talked about, like, if you took a picture of someone's face and you pull it out one way, but not like, when you're playing with pictures and like,
When you take a picture,
Word or whatever.
When you like take a circle, and it turns out to be square.
I don't know what's wrong. All right. Example, let's say if I take a shape and I drag one side of it out, that's going to take it from being a square to being a rectangle. Or if I take it just from the bottom and stretch it this way, it's going to be a rectangle. But if I take it from the corner and I drag it out this way, then it's going to be wider and longer. So it's still going to be the same shape, just a different size, right? Okay, so another example that they'll use with indirect measurements is talking about, like, okay, let's say that, you are trying to blow up a picture because, you want to put it on, a big poster, for school or something. Well, if you know that the picture is initially 5 by 8, okay, well, let's say it is 5 by 8, and then you want to put it onto a poster board, and your poster board is, let's say, 36 inches tall and 48 inches wide. Now, if you want to put that picture on here, and you want to put it right here in the middle.
That's a rectangle.
Well, yeah, it's a 5 by 8 picture, so a 5 by 8 is going to be a rectangle, right? So let's say it's an upright picture, up and down, and you want to put it right here. So you want to make sure that when you blow it up that it's going to fit, right? If you're going to, print it off and then you're going to glue it onto your poster board, you don't want to end up printing it off too big to where it's hanging off on the edges, right? But you also don't want it to be too small. You want it to fill up the poster board, right? So you need to know how big it needs to be. So you know that this measurement has to be what?
36.
Well, the poster board is 36 inches tall, right? So the long measurement needs to be no more than 36. And let's say you wanted to give it an inch on top and bottom, a little border or whatever. Then you could say, okay, we'll make it 34 inches tall. Now, if I was looking at that and my original is 5 by 8, and this one has to be 34 by what?
That's a really big picture. 40, 46. 15.
That's our unknown. It can't be by 46 because if it's a 5 by 8 picture, it's going to be taller than it is wide here, right?
29.
So this is our longer side. Our longer side is 34, so we would have to set up
11.
a proportion to solve this, okay? I know that it can be 34 inches tall, which is the length of the picture. So I've got, this is 34, and this is my unknown quantity, right? If I want to make it fit on this poster board, then it can't be any taller than 34 inches tall to have that 1 inch border. But then width-wise, I'd have to solve. So now I have similar figures. 5 compares to X, right? Because 5 is the short side and X is the short side of this picture. And then 8 compares to 34. And then once I've got my proportion set up, it's just a matter of solving. Hang on. 5 times 34 divided by 8. So 5 times 34 divided by 8 is 21.25. So this would have to be 21 1/4 inches wide.